Welcome to 5-Minute Papers on AI for the Planet. I'm Grace Lindsay. Our paper today is ClimateBERT, a pre-trained language model for climate-related text. Let's get started. Large language models like those that powered ChatGPT and Gemini are everywhere today, and they're capable of many impressive feats. But they can sometimes struggle when asked to perform tasks involving niche or technical language. And the reason for that has to do with their training data. When constructing a large language model, researchers first train the model to perform a very simple task on a very large corpus of data. For example, the task may be to predict what word comes next in a sentence, and the data set is basically all the sentences on the internet. Through this, the model learns the statistics of language, what words normally co-occur with what other words and in what order. And from this, the model comes to represent a form of meaning. But this means that the statistics of the language the model was trained on are going to be very important for the meaning the model learns. And technical terms related to climate change, like radiative forcing or carbon intensive, aren't going to show up much in a big general language dataset. That makes it harder for the model to learn the precise meanings of these terms. So what this paper does is use a method called domain adaptive pre-training to give these large language models a little extra infusion of climate knowledge. Here's how it works. The researchers first start with a model that was already trained on a general large language dataset. In this case, they use the Roberta model, which is trained to predict missing words in the middle of sentences, which are pulled from news articles, books, and Wikipedia. Then they collect a new, smaller language dataset that contains the technical language they want the model to learn more about. Specifically, the authors collect a dataset that combines climate change-related news articles, abstracts from climate-related research articles, and corporate sustainability reports. Through analysis, they're able to show that this new dataset has substantially different statistics than the general text the model was pre-trained on. The model is then further trained to predict missing words from this climate text corpus only. The hope here is that the model will be updated enough to reflect the meaning of climate words without interfering too much with the model's representation of language more broadly. And it seems to work. Their domain-adapted model, which the authors called ClimateBERT, learns to better predict missing words from these climate-related texts. This can be seen by comparing the loss value between ClimateBERT and the original Roberta model. But just being able to predict missing words isn't actually helpful. We want the model to be able to do useful analyses for us. So the authors also evaluate the model on 3 downstream tasks of interest. For each of these tasks, a special readout layer is trained on top of the final layer of ClimateBERT in order to indicate the model's decision. The first task was to classify if a given paragraph contains information related to climate change or not. Here, domain adaptation gives a bit of a boost to the F1 score, which measures the model's overall classification performance. The authors also noted that if they did their domain adaptation with a subset of the climate data that was most similar to the paragraphs to be classified, the performance is even better. This shows that these models can be adapted for very specific contexts. The next task was sentiment analysis. Does the paragraph contain information about a negative climate risk, a positive climate opportunity, or just neutral climate information? Here again, ClimateBERT shows significant increases in performance over the baseline Roberta model. Finally, the authors evaluated a form of fact-checking, where the model needs to determine if one sentence supports or refutes the claims made in another sentence. On this task, not only does ClimateBERT beat the baseline Roberta model, it actually beats the previous state-of-the-art model on this task as well. Since ClimateBERT was published in 2022, it has been put to good use by researchers studying the societal response to climate change. In one example, ClimateBERT was used to analyze what companies are saying about their climate-related risks in their financial disclosure documents. The conclusion was they're not saying very much of substance. One thing to know about large language models like ClimateBERT, though, is that they have their own climate impact. These are big models churning through huge data sets, and that means that they use a lot of compute, the energy for which usually comes from fossil fuels. In fact, the authors of this paper report that running the domain adaptation for ClimateBERT caused an estimated 115,000 grams of carbon dioxide emissions, which is equivalent to burning about 13 gallons of gasoline. The authors were able to keep emissions relatively low for this work because they used a small pre-trained model and limited the runs needed for hyperparameter tuning. So, when used wisely, this work shows how large language models can assist in the fight against climate change. That's all for this episode. Remember to subscribe to this channel for more examples of how AI can be used to help protect our planet.